This is TMUA 2021, Paper 2, Question 13. We've defined the region R on the plane to be the area satisfying y minus x is less than 3 and y minus x squared is less than 1. And we want to know which of these statements is true for every point in R. Statement 1 is saying x is between 2 and minus 1. Statement 2 is saying y minus x times y minus x squared is less than 3. And statement 3 is saying y is less than 5. So let's try and work out what our region R is. So let's just try and sketch it. So we need to work out what the two components of the region are. So the first one is y minus x is less than 3. Rearranging that, it gives us y is less than x plus 3. And this is precisely a straight line with gradient 1 going through the point 3. That's when we have equality. So when y is less than x plus 3, which side of the line are we allowing? So because y must be less than this, we want to be in this region. So if I shade the region that we're not allowed to be in, it means we're disallowing the region above this line. So now how about the other curve? Y minus x squared is less than 1. Well, we can also rearrange this to get y is less than x squared plus 1. So if we set this equal to this inequality to equals, then we can get an idea of the boundary of this inequality. And this is precisely a quadratic y equals x squared shifted up by 1. So we're going to get something that looks like this. And notice we're going to get intersections at 2 points. And then what is the region that we want? Because y is less than x squared plus 1, we want the region below this graph. So we want to shade the region above it. So we've shaded this bit, and we note the two intersections here. So what is our region R? So the region R is basically the region that is not shaded. So it's precisely going to be this region here, following this blue curve. So now we've got our region R. Let's analyse our three statements. So statement 1 is saying x is between minus 1 and 2. That's saying something like x must be between like two fixed regions here. This seems false, as we can just choose a point really far to the right, as our region R just goes off to infinity. There's no real restriction on the end limits of R. So 1 is false. What about statement 2? This is saying y minus x times by y minus x squared is less than 3. This is true. Statement true is true for all x. We don't know if this is true. So how might we test it? So we can just set x equals a fixed number to maybe make our lives a bit easier. So let's say x equals 0. So now our curve becomes y squared is less than 3. So we're on this line. Does every point in R satisfy this inequality? Well, no, you can just choose a point really, really low. So y, maybe where this brown bit is. And then the squared of this can obviously be bigger than 3 if you choose this brown point to be sufficiently low. So giving a concrete example, you can say the point 0 minus 4 is in R, but minus 4 squared is bigger than 3. So statement 2 does not hold for every point in R. What about statement 3? That's saying y is less than 5. Well, no, we can just choose this purple point here, and because this R goes off to infinity, we can just choose a point really far to the right and really high up, and that will still be in R, but would have y value bigger than 5. So it's absurd. So the answer is A, as none of these statements are true.